So today we're doing this problem from practice exam 10. Square is inscribed in a circle. The radius of the circle is blah, blah, blah. What is the side length in inches of the square? So to do this problem, it's really useful to know the 45, 45, 90 triangle. This is something that's kind of useful. If you're going to do any kind of STEM field, it's good to know these triangles. And even if you're not going to do STEM, if you're going to do anything in science or whatever, it's useful to know. What is a 45, 45, 90 triangle? A 45, 45, 90 triangle has the angles 45, 45, and 90. It would basically be a square that's cut in half diagonally, right? So if you had a square that every side is 1, then the 45, 45, 90 triangle would have two sides that are length 1. And then to figure out this diagonal length, all you'd need to do is do Pythagorean's theorem, right? If you do Pythagorean's theorem, this would be 1 squared plus 1 squared. So this would be 2 square root, right? So 1 squared plus 1 squared equals c squared. So c would equal, c squared is equal to 2. So c is equal to square root of 2. So this side here would be square root of 2 if this is 1 and this is 1. Another useful combination would be if you had a 45, 45, 90 triangle and these two sides were 1 over square root of 2. Because then if you did Pythagorean's theorem, this would be 1 over square root of 2 squared, which would be 1/2. This would be 1 over square root of 2 squared, which would be 1/2. If you add 1/2 together, that would be 1. And so this would be square root of 1, so it would just be 1. So these are like the two possible, or the two most popular combinations. You have square root of 2 here, you have 1 here, you have 1 here. That's a 45, 45, 90 triangle. You have 1 on the hypotenuse, 1 over square root of 2, 1 over square root of 2 on each side is also possible. Now, a lot of teachers like to rationalize this. So you would have square root of 2 over 2 here and square root of 2 over 2 here. Same thing, right? 1 over square root of 2, if you wanted to put a rational number in the denominator, you would multiply both the top and the bottom by square root of 2. And if you do that, you'd have 2 on the bottom and square root of 2 on top. Okay, so this is just a long way of saying that if you have 45, 45, 90 triangle, you would have these orange ratios, or you would have these blue ratios between the legs and the hypotenuse, right? So in this particular case, it's useful to know that. It says that a square is inscribed in a circle. I always advise people to draw a picture. So you have a circle, and I'm going to inscribe a square inside of it. Inscribe means that it's written inside as big as possible. So it would be like that, right? So I have a pink square inscribed inside of a blue circle. The radius of the circle is 20 square root of 2 over 2. What is the side length in inches of the square? So the radius of the circle, I think it would be best to draw the radius not like this, but like this, because you're actually connecting it with part of the square, right? It becomes kind of like half the diagonal of a square. So the radius is this, and this radius is 20 square root of 2 over 2. Okay, and there's a reason why they didn't cancel out this 2 here. They left it as 20 square root of 2 over 2 because it makes it easier for them to say, oh, the entire square would be double this, okay? So what is the side length in inches of the square? So first, I think the quickest way to do this is to figure out what the length of this diameter is, right? Because if you have the diameter, then it would be the diagonal of the entire square. Notice that the diameter is equal to twice the radius, so that would be 20 square root of 2 without the 2 on the bottom, right? That's why they divided it up here and put the 20 on top and the 2 on the bottom, so they could easily make it into a diameter by taking out the 2. So now we have that the diameter is equal to 20 square root of 2. Now we can compare it to the ratios here. Notice that if this is 20 square root of 2, then this and this must be 20 and 20, right? Because the relationship between here and here is multiplied by square root of 2. Here and here multiplied by square root of 2. The relationship between here and here is multiplied by the square root of 2. So that's why we know that if this diameter is 20 square root of 2, then this side is 20, right? Do you see how we never actually had to do Pythagorean's theorem or take square roots or anything because we've memorized these orange ratios? So now we know that the side of this pink square is 20. That means this answer would be A.